What's going on, guys? Welcome back to another episode of Triangle Diagnostics. We're currently sitting in front of this beast, this 2003 PT Cruiser. It's got the 2.4 four-cylinder engine in it, non-turbo. The issue we're going to be dealing with today, and this car's got some problems, guys, but the one we're going to be addressing is the AC doesn't work. I initially pulled this vehicle in and I turned the AC on. I confirmed that it was in fact not working. When I took a step out of the vehicle, I heard a loud hiss and looked under the hood, and what I basically saw was the AC compressor venting excess pressure. So that could point potentially to a few different things. One thing it could point to is a huge overcharge condition. I don't believe that's the case. It's just sort of started happening to this guy. The other one would be some sort of cooling fan issue. I'm not sure what we're looking at on this one yet. So I think just initially what I want to do is I want to get you guys focused in on the engine compartment. I'm going to turn the vehicle on, turn the AC on. We're going to see if these cooling fans come on or not, and maybe you'll get to see this thing venting R134 to the atmosphere. Ugh, hopefully not, guys. I don't really want to do that, but yeah, I'm going to get you guys focused on the engine compartment, start the car up, and
Alright guys, so we're inside the car here, and one thing I wanted to show you. Hopefully you guys can make that number out. Yes. The cluster's not lying, guys. This 2003 PT Cruiser only has 34,000 miles on it. Pretty wild. But anyways, not our focus. I'm just going to stick the key in the ignition here, and we're going to start this puppy up. Here's some very, very annoying beeping. Whatever. But all I'm going to do at this point, guys, I'm just going to turn this AC on. So moving the selector over, the blower motor's already on. And now we're going to go take a look out in the engine compartment to see what we see. So as you can see, I already have this air box removed because I have a little bit of a direction where we're going with this. And I don't know if I'm going to be able to show you this here. Maybe if I grab a light, give me 1 second. Alright, I got you guys back focused on this fan assembly. It's going to be pretty tough to see in here for you guys. But this fan's not spinning. Sorry, this engine's so stuffed in here, otherwise this would be a little bit easier to show you. But this cooling fan is definitely not on. The next thing I'm going to attempt to get a shot of is the AC compressor. And that's also going to be pretty much impossible to show you guys with how stuffed these units are in these cars. What I can tell you though is the AC compressor clutch is currently engaged, guys. And this fan is not spinning. So this is potentially looking like a cooling fan problem. The next step for me is going to be to get some description and operation of the system, see when these fans are supposed to come on, and we'll determine how we want to troubleshoot that based off of that. Alright guys, so the first thing I have printed out for this vehicle are some basic enable conditions for this, this fan unit. This has just one fan, guys, so it's going to be one fan that performs both the high and low speed functions on this vehicle. The one we're really concerned about is the AC on. If we look at this low speed block of this AC on, we see it says off. That's, I don't think that's right, guys. What I think should happen on this system is when the AC is on, I believe that the low speed fan is going to run all of the time. And then under certain pressure conditions or temperature conditions, the engine computer is going to energize the high speed portion of the fan. I'm not sure, guys. This is saying off for sure, but there's absolutely no way that's the case. So going forward with this, to try and keep this as easy and as quick and really just rudimentary as we can, is let's get a scan tool on this thing. Let's see what sort of bi-directional controls we have, and we'll see if this fan even works. Yeah. So let me get the scan tool hooked up, we'll go to the functional test menu, and then we'll start executing some of those tests. Alright guys, we're going to go ahead and identify our vehicle here. Oop, wrong year. Whoa. Alright, so we're working on a 2003, we're going to do the manual ID feature. This is a PT Cruiser, and we have the 2.4 non-turbo, so this guy right here. Initially maybe it would be a good idea to check trouble codes on this, so let's go ahead and do that. Go to codes, and all we have here is this oxygen sensor fault code. That's not going to help us with the issue we're dealing with, guys, so we're just going to back out of this. So we're back in the engine main menu. My basic thoughts on this, guys, is really I'm just concerned that this fan is bad or something and maybe it doesn't run at all. So what I want to do is I want to use the functional tests and attempt to command this fan on. That's going to give us some good direction as far as, are we looking at some sort of control issue or potentially a fan issue. So I'm just going to go to functional tests. I think it's under ATM tests. Yeah, just looking through here. So we have a high-speed fan relay there. We also have a low speed. Let's try the low speed first. So all this test is going to do, guys, is it's just going to turn this fan on for us, and we're going to listen to see if it actually comes on. So I'm just going to hit on this. I heard a relay click, but I don't hear the fan coming on. It sounds like this relay is cycling on and off. I'm just going to be quiet for a little bit so you guys can hear that. So I definitely don't hear a fan, guys. We're gonna come back out of this. So the next thing we can do is maybe this high-speed fan relay. I still hear this thing clicking in the background. It's a little odd. So we're on the high-speed fan relay of this portion here, guys. So what I'm going to do is I'm just going to hit on this. We're going to see if the fan comes on. And we definitely hear it. It's still being cycled on and off, it seems. But we can hear this fan that's coming to life and then going back off. So what this suggests is that the high-speed portion of this fan, I guess, is potentially working. Whatever controls this high-speed function is performing its job. So really, I think we need to worry about the low speed, kind of based off of this test. So being a little bit unfamiliar with this system, guys, the next step for me is going to be to look at a diagram and let's figure out what's all involved with this. So that's coming up next. Alright, guys, so I've got a diagram here of this system, and we're initially just focused on this top portion. What we have is we have this power distribution center. It's on the left side of the engine compartment. That's going to be the TIPM, I'm fairly certain, on this design. If we look, we have 3 different relays shown here. This is just an AC complete system wiring diagram. If we look here, we have this AC compressor clutch relay. If we look to the right, we have this low speed radiator fan relay. And then to the right, we had this high-speed fan relay. From the functional test we did, I think what we were doing is we were energizing this high-speed fan relay here, and we heard the fan kick on with that test. What we did not hear is the fan kick on using this low-speed fan relay. I'm going to zoom out a little bit and get you guys zoomed in on the fan motor itself. So this is the actual radiator fan here, guys. And if we just back out just a little bit, we can see that there's actually 3 wires going to this. One of them is going to be a ground coming here. Looks like left front inner fender. We're not really worried about that here, guys, based on the fact that this fan does run. What we really need to be worried about are these other 2 wires coming off of it, the wires that control it. If we look up here to this low-speed radiator fan relay, it's got this dark green wire that comes down directly to the motor. So this is going to be power side control from the low-speed fan relay. So when the engine computer energizes this relay and provides power on this wire, this fan is going to run at low speed. I'm not sure exactly how they're achieving this. What I'm assuming is taking place is there's some sort of resistor built into this motor unit that's basically causing a voltage drop across that resistor and potentially only sending 6 volts to this motor. Not 100%, but that's probably how they're doing it. If we look on this other one, this yellow wire coming from this high-speed fan relay, we see that going directly to the motor as well. What I'm fairly certain is happening here, guys, is it's just going to send 12 volts directly to this fan. There is not going to be any sort of internal resistance in this fan unit, and therefore the fan is going to run on high speed. So we know that the high-speed fan works, guys. So there's a couple of things that we can rule out as possibilities, for this particular circuit fault. If we focus back up here on these relays, I'm just going to focus on this low speed and the high speed. We can see that the load sides of these are both fed from the same fuse, this fuse 5. It would be a waste of time to check this fuse, guys, simply because this fan does run off of this high-speed radiator fan relay. So we know that this We know that this fuse 5 has to be good without a doubt, so we're not going to waste time checking that. You know, could we have a wiring issue from this fuse to the relay? Absolutely. You know, I'm not sure what we're going to find yet. Kind of getting into the controls of these relays. I'm just going to show you guys how they're controlled here. If we follow this load speed control side here, one side comes up here, as well as the high speed, one side comes up here, and they both splice together, and they come over here to this fuse 12. Let me get you guys zoomed a little bit better in on that. So this fuse 12 here, guys, that's going to supply a power feed to the control side of all three of these relays, the AC compressor clutch, the low speed fan, and the high speed fan. So we also know that this fuse is good. There's no reason to check it based off the fact that, one, our AC compressor clutch is engaging, and two, this high speed fan is coming on with a bi-directional test. So really at this point, what we need to be concerned about is we need to be concerned about this relay itself. And for me, what I want to do is I want to go directly to this radiator fan relay and test it directly. What we need to be looking for when we test this relay, at least initially, is we know there's going to be two power feeds. You know, we're going to have load side power coming from this 40 amp fuse here, fuse number 5. And we're also going to have control side power coming from this fuse 12, which also provides power feed to these other three relays. So what we're going to do, guys, is we're going to install a relay test tool in here. And for our initial first test, we're just going to look and make sure we have two power feeds at this low speed fan relay. As far as the controls go, we'll get into that on the car. But what I can tell you is the engine computer down here is providing ground side control for all three of these relays. So let's go to the car, get a relay tool installed, identify our relay, and let's test for two power feeds at this relay and make sure we don't have an issue there. So that's what we're going to do. Alright guys, so in order to really get to this box and be able to show you guys exactly what we're doing a little bit better, what I had to do is pull the air box out. I just had that sitting on the ground here. And I've already got the cover of this box off. It's right here. And if we look at this box, I'm just going to kind of prop this here so we can maybe get a better look at it. Let me see here. Yeah, that should work. So I'm going to zoom into this area of the box right here. And what we can see is this top left one here. That's going to be the high speed fan relay, guys. That's not the one we're concerned with on this one. We're concerned with the low speed. And I've identified it on this diagram. It's going to be this larger relay down here at the bottom left. So if we take a look at this fuse box, what we can see from looking at both this diagram and this actual fuse box itself is this is our guy right here. So there's a couple of different ways we could test this, guys. But really what I want to do is I want to remove this relay, and I want to put a relay terminal testing tool in this. That way all of the internal circuits of this relay are exposed, and we can test it using a simple test light. So I'm going to get this pulled out and get that installed. So this is the tool, guys. All I did was I just took this relay, this thing's sitting up here, and I just slipped it down into this tool. And what it's doing for us is it's allowing us to have access to all of these terminals here. So I'm just going to plug this back into the fuse box. And I kind of test fit this already, guys, and something that stinks a little bit is you guys can't see the terminals, from your location. All you guys can see is the back side of the relay there. But all I'm going to do, guys, when we were testing, or when we were looking at the wiring diagram, we knew that we had two power feeds going to this relay. One was control side power, the other was load side power. All I want to do at this point is I just want to go down the line on this, test all 5 of these terminals. And what I really want to see is I want to see 5 power feeds. To keep this fairly low tech for you guys, what I'm going to do is I'm going to use a test light. So let me get a test light and then we'll start testing these. Alright guys, this is my tool that we're using. You can see it's a test light. I'm hooked to ground. My test light is currently touching battery positive, and we can see that it lights. So all I'm going to do here, guys, and I'm just going to try and get this to where you guys can see it, is I'm just going to go down the line and I'm going to touch all 5 of these contacts on this relay. And what I'm looking for are 2 power feeds. So I'm going to start from you guys' left. Nothing on that one. Moving to the next. We see we do have 1 power feed. That's 1 out of 2. Moving to the next one. Nothing. The next one we see a second power feed. That's our last one. That's good. And then our third one. Nothing. So what we've confirmed at this point, guys, is our 2 power feeds are present to this relay. So our next step is going to be to verify control of this relay. The way we're really going to do that is we're going to use we're going to continue using the scan tool, and we're going to get the scan tool to functionally command this low-speed fan relay on for us, and then we're going to verify control of that relay via two methods really. One, we're going to hear this relay clicking. That's a good indication that you do have control and the control circuit's functional. The next thing we're going to do is we're going to use this test light. We're going to change its polarity to positive since this engine computer is grounding this relay to control it. And then we're going to look for the flash of our test light to tell us that as well. So let me get that set up. Alright guys, so this is the test. I realize you guys aren't going to be able to see the Varus very well. Not really important for this. All I'm going to do here guys, I'm back into my low speed fan relay functional test, and I'm just going to turn this test on. As we can see, we hear a relay clicking on and off. I'm now just going to use this test light to test this relay. So what I'm looking for is I'm looking for a ground from the engine computer. So I'm just going down these terminals and I'm looking for that ground, and we found it. It's that first pin there. We can see the engine computer is illuminating this test light by supplying a ground on this control terminal of this relay. So what that does at this point is it verifies good computer control of this relay. Wiring integrity to the engine computer is good. So now we need to move on to the load side of this relay at this point. So the way we're going to do that guys is, when you think about what this relay does, it provides a power feed to this low speed fan. So in order for us to test for load side power out of this relay, what we need to do at this point is move our test light back over to ground. We're going to check and make sure it lights. I'm just touching battery positive. So we had two power feeds before on this guys, control side power for this relay as well as load side power. What we're looking for now is output power from the relay. This is also going to flash on and off when we find it from the relay doing its thing. And we can see it clearly there, on and off. There's on, there's off, there's on, there's off. So this relay is good guys, absolutely nothing wrong with it. It's being controlled properly by the engine computer, and it's also sending load side power through its contact switches. So really, we've proved out the PCM, we've proved out the relay. Our next step is we want to go down to the fan and we want to take some measurements there and see if we are actually in fact getting power down there. So that's coming up next guys. Alright guys, so I lifted this vehicle up. Now what we need to do to test this fan, I couldn't access any of the wiring for it on top of the vehicle, so I had to put it up in the air. Where we're looking is this area right here in front of the transmission pan. We can see this electrical connector. They're all pretty heavy gauge wires. We see a black, we see a yellow, and we see what appears to be a green there on the left. This is the connector for this fan control motor guys. This is where we're going to be doing our final checks at as far as this fan is concerned. But and we're really just worried about one side of this. Remember from our diagram before, we had one ground going to this fan motor, and then we had two separate power feeds coming from the high-speed fan relay and the low-speed fan relay respectively. What I'd like to do real quick is let's revisit that diagram. Let's identify which one of these wires is going to be for the low-speed side of this, and then we're going to install a T-pin in that and we're going to test that. So back to the diagram. Alright, so we're real quick guys, we're back to the diagram. We're just looking at this radiator fan motor. As we can see, those two power feed wires coming off. We see this yellow one here, that goes to the high speed, and then this dark green one, that goes to the low speed. We confirmed all of these colors on the car. Those are the colors of the connector. So what we're going to do is we're just going to back probe this dark green wire here, and we're going to use a test light to test for control when we manually energize this radiator fan relay using the functional test of the scan tool. Alright guys, we're doing final checks on these on this cooling fan assembly. I'm just going to use this T-pin to back probe this connector. I have a test light here. I've already confirmed that we're hooked up to a good ground, so when this finds the power, it's going to light. All I'm going to do at this point, guys, is I'm just going to turn this bi-directional test on the scan tool on. It's currently on. I don't know if you guys can pick it up, but we hear some clicking. So while we hear this clicking, guys, I'm just going to take this test light here, and we're going to touch this T-pin, and we're going to look for this control. And as we can see, it's lighting. So guys, what this tells us is this cooling fan is defective, no question about it. We definitely have a power side control here, and based off the fact that the high-speed fans run, we definitely have a good ground.
We can check that real quick if you want, guys. I'm just going to move this T-pin over. My test light is still hooked to battery positive. I'm going to hook to this ground. What we want to see is our test light not to light, and we can see this is a good ground. It's not lighting. We still hear the relay clicking. So really, we're pretty much done here, guys. This thing needs a low-speed fan assembly, and really, it's just going to be the whole fan. You know, one thing we could try to do is we could try to get this fan working again, maybe. Maybe I'll show you that. I'm gonna see if I can zoom you in to these blades. I think you can actually see them. This relay is still going. I'm just gonna take my flashlight and I'm just gonna start whacking this thing around a bit. See if I can get it moving, guys. Does not appear to be working. Hopefully you guys can see that. Get this light out of here. Oh, did you guys see that? Oh man, it wants to work. Oh, there it goes. Yep, there it goes, guys. So we were able to get the fan working again just by tapping on it. It's working pretty bad. It's hardly spinning, but you guys can clearly see it's definitely working. So that's pretty much it, guys. Let's get this car back on the ground and let's talk about what we found. So that's pretty much it for this one, guys. You know, just as a kind of a brief summary, this vehicle came in, the AC didn't work on it. I pulled it into the bay, noticed that, you know, that was the case. The AC was definitely hot. When I initially got out, and that was something I did off camera, when I got out of the car, I heard the AC compressor vent. So I knew we had some sort of overpressure condition occurring. Really, it was just kind of experience that told me to look at the fan. If you have high pressure, enough to make the compressor vent, you know, really the fan would be a good place to look. As I said before, an overcharge condition could also potentially cause this. But it was really just experience that pointed me to look at the fan first, and we kind of took off with that. I wish I kind of would have had you guys there for that initial checkout, but I had you there through the whole diagnosis. But really, we learned some good lessons on this one. We learned how to test a motor. We learned how to test a relay. You know, basic wiring diagram analysis, and it was pretty cool at the end there. We were able to tap on the fan motor and get it to work again. So confirmed, this thing needs a fan motor, guys. That's really pretty much it. That's the only way this car is going to get fixed. I'm pretty surprised they didn't have any sort of overheating issues or anything like that. But as for this one, guys, 2003 PT Cruiser, it needs a fan. So that's it, guys. You know, thanks for watching. Thanks for your continued support. I'm going to keep cranking videos out to you guys. If there's anything you guys want to see, you know, just leave them down in the comments, and I'll be on the lookout for them. You know, if I see a particular car you guys are interested in seeing a video on, you know, I'll do my absolute best to film it. So thanks, guys. It's been another exciting episode of Triangle Diagnostics. So catch you next time.